Okay, guys, so today that we are going to learn how to model a quadratic function um, using our calculator, list and spreadsheets. We use list and spreadsheets with linear functions, so it's pretty much the same steps except there's one small thing. Instead of picking linear, we're going to pick quadratic. All right, so in my table, I know I have I have values of x's and I have values of y. So what I'm going to do is I'm going to go to list and spreadsheets in my calculator. So remember, step one is up here in the A box, we're going to put an X. In the B box, we're going to put a Y. Then what I'm going to do is I'm going to enter my data from my table. I'll go up and now list all my Y values. Okay, remember you want to be in a box that's underneath all of your data entry points. Okay, so now that I'm under here, from here we press menu, 4, 1. Okay, we used to pick 3 because it was linear, but now we're in quadratics, parabola, so I'm going to go to 6, 4, 1, 6. I'm going to type my X in X list, Y in Y list, and I'm going to click enter twice. Okay, from here you should see that it tells you an A, a B, and a C. So go ahead and write that down on your notes. Okay, and the way we're going to write that is because the equation in quadratic form is written as y equals ax squared plus bx plus c. So that a, b, and c value that we just found, we're going to replace. So my equation would be y equals, instead of ax squared, it's 1x squared. Instead of plus bx, it's going to be a minus 6x. Instead of a plus c, it's going to be a plus 1. Okay, now it's asking for the vertex. So what I'm going to do is I'm going to go back to my calculator from here. So I'm going to add a graph. To remember, in order to do that, we press Control Dock. We're going to click Graph. Okay, notice this box is empty, so it will graph it for me, but I got to click the Up button first, and then click Enter. Notice this equation is what we wrote. Okay, so question C is asking for the vertex, which is going to be down here. So I'm going to use Trace, Menu 5-1. So I'm going to move my cursor until I get to that very low point. Minimum. Okay, so notice minimum is in my way. So over here, if I just put my finger on my touchpad and wiggle it around, it'll get out my way. Okay, so my vertex is at 3, -8. My y-intercept, so let's move our cursor until we're on top of the y-axis. So my y-intercept is at 0, 1. Okay, now it's asking for zeros on question F. Remember, that's where it touches the x-axis. So here and here we'll have 2 of them. So I'll move here first. It's the x-intercept. So I'm going to write down my x value, which is 0.172. And there's another one over here. So I'm going to swing it around over there. So my other x-intercept is at 5.83. Okay, keep in mind this is a parabola that opens up, so we're going to go sketch this on our paper. And we said the vertex was at 3, -8. Okay, we're going to use that in a second. Okay, so this is what we should have so far. Okay, we said that our vertex is at 3, -8. Now it's asking for the axis of symmetry. We know the axis of symmetry splits it in half. Axis is spelled with an X. So I'm going to put X equals. I know the axis goes through the vertex. So I look at my vertex and I know the x value is 3. Okay, so the reason I sketched this picture here is because I want to do domain and range real quick. Domain is how wide, range is how tall pretty much it is. So domain, left and right. So slide to the left, I notice it will go forever. As I slide to the right, it will go forever as well. So that is all real numbers. Range is how far up or down. I know it will go up forever, but I have my low point here at the vertex. So range is y. It goes forever up, which is greater than or equal. And it goes forever up from this vertex. So I look at these two numbers. Range is y, so I take the -8. Okay, it wants me to evaluate h of 4 and h of -2. So remember, these numbers on the inside are x values. So trace looks like an x. So I can jump to any x value I want. So since I'm already in trace, I'm going to jump to where x is 4. So to do that, I'm going to click 4, enter. Well, when x is 4, I know my y value is -7. So h of 4 is -7. The next one asks for h of -2, so now I'm going to jump to where x is -2. So I'm going to type in -2, enter. So when x is -2, I know my answer is 17. Okay, on this piece right here, guys, it's asking to evaluate h of x is equal to -7. Well, I know that this means y equals -7. Okay, well, here's the problem with trace. Trace goes to x's, not y's. So I can't use trace. What I'm going to use is table. Control T. I know I want my y to be -7. So I don't want to look here. Those are x's. I want to look in the second column, y. Well, I see y is -7 here, which means x is 2. Y is also -7 here, so x is also 4. So when y is -7, x is 2, but it's also 4. All right, so we're going to do that again. Let's go ahead and go to List in Spreadsheets and put in our data. Remember, you put an X in the A box, a Y in the B box, and then enter your data. Make sure you're underneath all those points, and then we're going to press Menu, 4, 1, and remember it's 6 because it's quadratics we're dealing with now. So X in the X list, Y in the Y list, click Enter twice. So we have our A, our B, and our C. So I'm going to write those values down. Okay, so remember the equation will be y equals ax squared plus bx plus c. So my equation is y equals, instead of ax squared, it's 3x squared. Instead of plus bx, it's going to be plus 1x. And instead of plus c, it's going to be a -3. So to find the vertex, I'm going to graph it. So from here, I press Control Dock. I click my graph. Remember to press up and then enter. Notice this is the equation we wrote down. So use trace to find your vertex. So your very low point, my minimum. So I'm going to write that down by vertex. Write this right here by vertex. So in parentheses, -0.167, comma, -3.08. It's also asking for the y-intercept, so I'm going to move it to where it's on top of the y-axis, which is here at 0, -3. My zeros are where it crosses the x-axis, so it crosses here and here. It doesn't matter which one you go to first, so I'll move here. It's my x-intercept, so I write down the x value, so 0.847, and swing it around to your other one, which is at -1.18. Okay, also, keep in mind what this looks like. It's a parabola that opens up, so we're going to sketch that here in a sec. So this is what you should have. And like I told you, I want to sketch it. We said this vertex was at Okay, remember your axis of symmetry cuts it in half. Axis is spelled with an X, so it's X equals. Always goes through the vertex. So the X of my vertex is this guy, so X is equal to negative 0.167. Okay, we sketched a picture of it because I wanted to talk about domain and range. Domain is how wide, range is how tall. So domain is left and right, so as I trace it to the left, I see that it's going to continue forever. As I trace it to the right, it also continues forever, so that's all real numbers. Range is how far up and down. Well, it will go up forever, but it does not go down forever. This is the lowest it goes. So one stopping point, range is y. It goes up forever, so that's greater than or equal. And it goes up forever from this point. Well, range is y, so I take the y value, which is negative 3.08. Okay, so to evaluate f of 2 and f of 0, remember the number on the inside are my x values, so I can use trace for that. Notice it already looks like an x, so I know I'm in trace. The first x value is 2, so I click 2, enter. So when x is 2, my answer is 11. Next one said f of 0, so to jump to where x is 0, I type in 0, enter. When x is 0, my answer is negative 3. Okay, on this one, remember this means y is equal to 11. So trace was no good for us there because trace only jumps to x's, it will not jump to y. So if I want to find where y is 11, I'm going to open my table, Control T. Don't look here, these are x's. I want to look under the y's for 11. Well, I found y is 11 here. My x value is 2. So on this next one, we're talking about the height of a ball after it was projected into the air. We need to find the equation. So on this one, it doesn't give us a table, but it gives me a graph. Remember, you need at least 3 points. Well, this graph, I see 4 perfect points. So what I'm going to do is I'm going to turn those 4 perfect points into my own table. Before I do that, I want to see what each of these axes are counting by. So I know my y-axis is counting by tens. And I know my x-axis is counting by halves. So this is a half, 1, 1.5, 2, 2.5, 3. Okay, so this point right here, it is at 0, 0. This point is at 280. Be careful on this next one. This one is at 2.5, 80. And my last point is at 4.5, 0. Okay, so now that I have a table, what I'm going to do is I'm going to go type that into list and spreadsheets. So x in the A box, y in the B box, and enter our data. So x's were 0, 2, 2.5, 4.5. Oops. My y values were 0, 80, 80, and 0. Make sure you're underneath all of that data, and then we're going to press menu 416. Remember, it's quadratics. Oops. Menu 416. Okay, X list, Y, enter twice. Okay, so I have my, oh, I don't like this. What did I type in wrong? Oh, excuse me, guys. Notice right here, it was 0, 0. So always be careful. Make sure you're underneath. Now that I fixed it, I'm going to press menu 416 again. X, Y, enter, enter. Okay. All right, so now I have my A, my B, and my C. So I'm going to write those values down. And it's y equals ax squared plus bx plus c. So my equation is y equals negative 16 x squared plus 72x plus 0. You don't have to have that plus 0 if you don't want it there. So now to go find my vertex, I'm going to add a graph. Control, dock, add my graph, click up, enter. There it is. And I'm going to use trace. I can see the graph that's on my paper. I know that it has a high point, so I'm going to move it to the high point. That's my vertex, so I'm going to go ahead and write that down. It says my y-intercept, so I'll move it to where I'm on top of my y-axis. Okay, this confuses some people because I know it says 0. We know 0 means the x-intercept. So we know one of our x-intercepts are 0 is at 0, so I'll go fill that in on problem G. But notice, 0, 0 is the origin, which means it's on top of the x-axis and it's on top of the y-axis. So not only is this a 0, but it's also the y-intercept. So my y-intercept is at 0, 0. Okay, so let's move it to my other 0. So here's one of them. It also crosses the x-axis over here. So I'm going to go up and around, swing it around. Touches the x-axis. Boom, here at 4.5. So make sure all of our stuff matches. Okay, remember axis of symmetry is spelled with an x, so I'm going to put x equals. It always goes through the vertex. So the x of my vertex is 2.25. Okay, let's go jump to where x is 1 and jump to where x is 3. So since it's already in trace, I'm going to type in 1, enter. So when x is 1, I know my answer is 56. So now I'm going to jump to where x is 3. So 3, enter. My answer is 72. So all I have left is to talk about domain and range. So domain is how wide it is. Okay, so I can see where it begins and where it stops. So I actually have 2 stopping points. How wide is it? So I'm going to frame it. So I see it starts here and it stops here. So that's 2 stopping points. So it starts here at 0, the smaller number. Remember, we always put less than. I'm going to put or equals because everything's solid. Domain is x. I put another less than or equal. And so it started at 0 and it's going to come all the way over here and stop at 4.5. Okay, range is up and down, so the highest and the lowest. So it starts down this low and it goes up this high. Okay, so there's 2 stopping points. We put our small number first, which is 0. Less than or equal to, range is y. Another less than or equal to. Okay, this is where some people mess up. They want to say 80 and I can see y. But remember, your highest point is that vertex. So let's go look at our vertex. Range is y. So I know the highest it goes was 81. Alrighty, on this one, I need to go to where x is 0. Well, x is 0 is right here. And my y value is, I count, 1, 2, 3, 4, 5, 6, 7, 8, 9. So then I go to where x is 1. And I count up, and that goes up 5. Go to where x is 2. And my y value is 9. Okay, so now that I have my table completed from my graph, I'm going to go type this information into list and spreadsheets. So x, y. My x values are 0, 1, 2. My y values are 9, 5, 9. Menu 416, type in x, y, enter twice. Okay, so I'm going to use my a, my b, and my c to write my equation. So my equation will be y equals 4x squared minus 8x plus 9. So the next question is asking, what is the value of y when x is 4? So to do that, I'm going to go to my graph. Control Doc. Add a graph. Press up, enter. Menu 5-1 trace. So I want to jump to where x is 4, so I type in 4, enter. So my answer is 41. Let's make sure yours matches mine. All right, so last one. Let's go ahead and type this into list and spreadsheets. So x in the A box, y in the B box, enter my data. Now I'll go enter all the y values. Make sure you're lower and press menu 416. Type in x, y, enter twice. Okay, so there's my A, B, and C, so I'm going to write my equation. So y equals negative 3x squared minus 9x plus 12. All right, so to find my vertex, I'm going to add my graph, Control Doc. Add my graph, click up, enter. I'm going to use trace, menu 5-1. My vertex is at negative 1.5, comma, 18.8. And notice, keep in mind that this is a parabola that opens down. We're going to sketch that here in a second. My y-intercept, so I'm going to go to where I'm on top of the y-axis. My y-intercept is at 0, 12. My zeros, so I need to go to the x-axis, which is, here's one of them. So one of my zeros is at 1. And it also hits over here, so I have to swing it around and go to that other one as well. Negative 4. Okay, so remember I said keep in mind that it's a parabola that opens down. We said the vertex was at negative 1.5, comma 18.8. Axis of symmetry, we know axis is spelled with an x, so I'm going to put x equals. It always goes to the vertex, so I'll take the x from the vertex, which is negative 1.5. Domain is how wide it is, range is how tall it is, and that's why we sketched it. So as I trace it, domain, left and right, as I trace it to the left, it goes forever. As I trace it to the right, it goes forever. So the domain is all real numbers. Range is up and down. It does not go up forever. It has this high point, but it does go down forever. So one stopping point, range is y. Down forever is less than or equal. And so I look at the vertex, because this is the highest it goes. Range is y, so I know the highest it goes is 18.8.